Hi everyone, welcome back to the channel. If you're working with Java microservices or planning to build them, so this video might save you from serious production failures. So because today we are talking about why microservices usually fail in the production, though it works smoothly in the development. We are going to discuss about that. So let's take an example of broken system. So what happens actually? Suppose we have multiple services, right? So user service, order service, payment service. So everything was working perfectly in development. The APIs were fast. APIs means when we call from one service to other service, we use API call, right? So it used to be fast only development phase. But the moment we deployed to the productions, everything started breaking. Suppose in case the order service is down, it's kind of a broken system. Now everything gets failed, right? So let's discuss what are the reason behind this. So one thing is microservice chain. This is one of the biggest mistake the developers usually make. We split everything into the microservices. User service, order service, payment service. So this is kind of a valid services, right? If we split the order service also into two different service, that could cause a problem. So while splitting the services, we should consider that the real business problem will be one service, right? So by considering this, we should split the services. But usually what we do, we thought that service is the kind of smaller of a whole application, so we will split everything. But we forgot one thing. All the services depend on each other. So when one service fails, everything collapses. The another thing is network delay. So network delay in monolithic application, what exactly happened? Method calls are instant. But in microservices, every single call is a network request because we use an API call, right? So one API call might go through 4 or 5 services. So you are seeing here, so for placing an order, we are doing four API calls, right? So and something if one fails, so it fails the other, and each API call adds the other call, right? So now imagine one service becomes fail and one service becomes slow. So what will happen? Your entire system will be slow only. So every call will be network delay. So suppose the payment call is delayed, now everything is delayed only. The next is retrying loop jobs. So what we do when the service fails? We retry, right? So it's a kind of a good idea. But without limit, thought about it. If we forget to provide the limit on the retry. So what will happen? It will retry, it will retry, it will retry. More retries, more load, and more load, more failures. And suddenly your system is under attack from itself only. So retries can turn into a overload, and overload can cause a specific crash. Okay, so that could be a cause also. And one thing also that logs also is a problem. So logging chows, what happens? So now let's try debugging this. Your order service is down due to some reason, and you are debugging this one. So logs are no longer in single place because your services are different, right? So they are no longer in the different place. So one request travel through multiple services, and each service has its own logs. So to find out one small issue also, you are jumping across 5 different systems, and still there is no clear answers for this one. So logs can be also a problem. So next is, if you see the deployment chaos. What is deployment chaos? If you see, sometimes when we in the production we use versions, right, to update our application. Some certain bug fixes we do. For that also we do a patch release, right? So think about it. You are no longer deploying one application. So what we are doing? You are deploying a multiple services. You are deploying user service separately, order service separately, payment service separately. But think about it. Suppose your user service is V1 version and payment is also same version. Somehow your order service is incompatible. It's a kind of a different version, so different dependencies is there. So what will happen? So one small update breaks everything. So whenever we will release one patch, or when we will release an versions, so we must check the libraries are same, the versions are same, and whatever the changes we are doing, those changes are compatible to the other service also. So one update might break everything. So you are changing, you are doing update only to the order service, but it is changing the whole, it's affecting the whole application, right? So that's what one update can breaks everything. So another thing is also crash timeline. Let me show you what exactly happens in the real productions. Suppose due to some reason your DB is slow. So if the database becomes slow, the request starts coming timing out, because it will try for the DB connection, right? But after certain limit, it will do the timeout. After timing out, so it will try for retry and request. Whenever the retry increases, we already discussed, if the retry increases, the load will get increased and the system gets overload. And if the system gets overload, what will happen? The crash will happen. Everything crashes, right? So these are the common problems we face when we deploy a microservice applications in a in the productions. But yeah, we can avoid this. But here is the good news: we can avoid this really, and all of this can be avoided clearly also. So what we can do? We have a solution checklist. If you see here, we have a checklist. What we can do for logging? So we discussed that in the logging we have a different service. We can make use of centralized logging. What will happen? All the logs, all the service logs will available in a single place, so that it will be easier to find the root cause of the issue. Okay, there is no need of jumping one service to another service. Second thing is proper design. So for proper design, we need to understand the real business problem before splitting the services. So that thing we can do. Next is circuit breaker. Once the retry is failing or something is failing, we can do a circuit breaker. We can make use of that one. Then the retry limit. Whenever we are doing a retry, something fails, we should put a limit on that. After certain limit, we can come back and throw some error. We can provide some error logs on that. Then the monitoring. It's a very important thing. We should monitor everything. We can make use of the health check. We can make use of the API health check. Everything we can do over there. So we have to design our service very properly. So microservices are really very powerful, but only if we use them in the right way. If you found this helpful, so don't forget to like, share and subscribe, and I'll see you in the next video. Thank you.